Hey guys, I'm going to do a review on number 5 from the review packet. You will have a question on your quiz that is a lot like number 5. Give me 1 second to get rid of all this extra stuff. There we go. We don't need that there. Okay. It says that there's a point A, and it's on the unit circle. So immediately I see that it's on the unit circle, and I'm going to draw the unit circle. That's the first thing I will do. So here is the unit circle. It has a radius of 1. Obviously, that's a pretty rough unit circle. And it's centered at the origin as well. So I know those two things about this unit circle. All right, I also know that I've got this point A, which has an x value of 1/2 and a y value of radical 3/2. I know that it's going to be in quadrant 1 because both of those are positive. If it was in 2, 3, or 4, one of those or both of those would be negative. So I know that I'm in quadrant 1. So I'll start off by just putting a point here in quadrant 1, and I'm going to call that my point A. And I'll remind myself that that's the point 1/2 over radical 3/2, just because that's going to become pretty useful. If theta is the angle in standard position whose terminal ray passes through point A, so theta is here, what is the value of sine of theta? So sine of theta is going to be the opposite side over the hypotenuse side. We know a few of these values. For one thing, we know that the hypotenuse has a length of 1 because we're in the unit circle. We also know that since this is the point 1/2 radical 3/2, the x value is 1/2, which means this distance is 1/2, and this distance is radical 3/2. So we know those measures. So now we just have to write it down. The opposite side has a length of radical 3/2. The hypotenuse has a length of 1, which ends up just equaling radical 3/2. And make sure that you check we're in quadrant 1. All students, or add sugar to coffee. In quadrant 1, all of them are positive, so it's a positive radical 3/2. All right. I'm also going to do one of the problems on the back.